Good day, my name is Andre de Clerc, and today I will be speaking to you about the drivetrain mechanism of a mountain bike. This mechanism consists of the following components: a cassette, a chainring, a chain, a derailleur, and a shifter. A one-bar drivetrain will specifically be looked at. This means that the bicycle has only one gear fixed at the pedals of the bike. The cassette. The cassette is fixed at the rear wheel of the mountain bike. These groupings of gears allow riders to increase or decrease pedaling effort. The larger the gear, the easier the pedaling, and vice versa. The individual gears are called cogs. The modern cassette usually comes in 10, 11, and 12 cog groupings. The number of cogs is usually referred to by the word speed. Thus, a cassette with 11 cogs would be called an 11-speed cassette. The chain serves as a linkage between the chainring and cassette. It consists of outer and inner chain links. The inner links have smaller gaps compared to the outer links. The inner and outer links consist of two plates each. The chainring is fixed to the pedals of the mountain bike. The chain runs over the chainring and the cassette. Let's take a closer look at the teeth of the chainring. As indicated in green, we can see the thinner teeth of the chainring, and in red we can see the thicker teeth. These teeth alternate across the chainring. This is done to ensure more surface contact between the chain and the chainring. The larger teeth slot into the gap in the outer chain links and the smaller teeth into the inner links. The derailleur is responsible for moving the chain from cog to cog. The two small gears guide the chain from the chainring onto the cassette. The derailleur has a cable that runs to the shifter located at the handlebars through the bike's frame. This cable is held in tension by a spring in the derailleur. In this view, we can see that the derailleur has a parallelogram-like shape. Thus, if the tension in the cable increases, it flattens the parallelogram and pushes the derailleur towards the wheel. If the tension decreases, the parallelogram will expand and the derailleur will move away from the wheel. The shifter is found at the handlebars of the bicycle and is used to adjust the tension in the cable that runs to the derailleur. When the upper lever is pressed, the tension increases and the derailleur shifts up to a larger cog. When the lower lever is pressed, the tension decreases and the derailleur shifts down to a smaller cog. The shifter uses a ratchet system. This mechanism contains a torsion spring that keeps the cable in tension. The cable is wound around a housing when upshifting and is released when downshifting. A single gear shift is called an index. Thank you so much for listening to my presentation. That is all.